Alright, in this video we're going to talk about a pretty important concept that you may have run into before in something like a pre-algebra class. So we're just going to take it to a slightly higher level, and that is something called the greatest common factor. So a really simple example with just regular numbers. Okay, if I were, for example, if I were to give you the numbers 10, actually let's not make it 10, let me make it slightly different. Let's suppose I gave you the numbers 40, 60, and 80. And I asked you, what's the greatest common factor? That's another way of saying, what's the largest number that can evenly divide those three? Okay, what's the largest number? And there's several ways you could do it. The traditional way in pre-algebra is by making these factor trees. So basically factor tree means break down 40 into what multiplies to 40. So 2 times 20, and then 20 is the same as 2 times 10, and 10 is the same as 2 times 5. Okay, 60 is the same as 2 times 30, and 30 is the same as 2 times 15, and 15 is the same as 3 times 5. And every time I'm circling a number, that means we can't break it down anymore, because those are prime numbers. 80 is the same as 2 times 40, 40 is like 2 times 20, 20 is like 2 times 10, 10 is like 2 times 5. Okay, you might have already been able to tell what the common factor is. I just want to show you for numbers where it's not obvious, so you can't tell. Okay, the greatest common factor is going to be, what do they all have in common? So they all have a 2 in common. Okay, they all have at least one 2. They all have a second 2 in common. Okay, so I'm going to add these as we go. So they have two 2's in common. It looks like they do not have a third 2 in common, because 60 doesn't have a third 2, even though 40 and 80 do. Okay, it looks like they all have a 5 in common, so there's the 5 in common, and that's it. They have two 2's and a 5 in common. 2 times 2 times 5, that equals 20. So 20 is the greatest common factor of those three. So let's now apply that to variables. So if you look at these examples right here, we are looking for not only the largest number that goes into them, but also the largest power of n that they have in common, or x, or whatever variable we happen to be using. So in this case, 4n squared and 4, okay, the greatest common factor will be, well, we know for sure that the 4 goes into it. And then n squared and n, what's the largest power that they have in common? This one, this front term has an n squared, but this one doesn't. This only has an n to the first. So the only thing they have in common is n to the first. Basically, another way of saying that is you're looking for the smallest power of n that you see up here, because the smallest power of n, that's the one they have in common. So we need to take 4n and basically divide each of these by 4n. And now we're going to write it in something called factored form. So here's how you do that. Here's how you write something in factored form. You take the greatest common factor, which is 4n, we put it out in front of a parentheses. And then to get what's inside the parentheses, we just do each of these divisions. So 4 divided by 4 would be 1. N squared divided by n would just be n. Okay, if you doubt that, I just want to prove that to you. N squared is the same as n times n. So if you look, we can see that those both cancel, leaving us with just a single n, which goes right there. And then this one's easy. 4n divided by itself just equals 1. So this that I just boxed off, that is the factored form of the original problem. So the other ones are a little bit harder, but the same basic skill applies. So see if you can pause it and try to do numbers 2, 3, and 4. When you're ready, hit play and we'll take a look. Alright, so let's look at number 2. So notice that 2 of these numbers are negative, and usually if the leading exponent, meaning the highest exponent there, is n to the 6th, usually the greatest common factor we want to factor out is a negative. So it's going to be negative something. The biggest number that goes into 54, 48, and 30 turns out to be 6. And then the power of n they all have in common, another way of saying that's the smallest power of n, because that's the only one they all have in common, would be n squared. So that means we're going to have to divide each of these things by negative 6n squared. Now if you hadn't noticed that 6 was the number, suppose you had picked like 3 instead of 6, you'd be able to catch that when you factor, because you look back at what's in parentheses and you see that they're all divisible by a further number. So I wouldn't worry too much about that if you didn't notice that it was 6. So let's pull the negative 6n squared out in front of the parentheses. And notice we have 3 terms right here, so that means if we do it correctly, we should get 3 things in the parentheses. Negative 54 divided by negative 6 is 9. N to the 6th divided by n to the 2nd is n to the 4th. And by the way that we're getting that is just taking that top exponent and subtracting the bottom exponent. 6 minus 2 would be 4. Negative 48 divided by negative 6, so we're looking at this one right here. Negative 48 divided by negative 6 is positive 8. N cubed divided by n to the second means we subtract the 3 minus the 2, and that gives us n to the first. And you don't need to write the first there. I'm just doing it so you can see where we're getting it from. And then finally, 30 divided by negative 6 is negative 5, and n squared divided by itself cancels completely. So our final answer is what I just boxed off. Here's a really easy way to check. Just take this thing in front and distribute it, meaning multiply it to each thing in the parentheses. And if you do that, you'll wind up exactly back where you started at the original problem. So that's really the easiest or the best way to check. And with a lot of these problems, it's never a bad idea to check. All right, number 3, if we look, there's 4 terms here. If we look at the 4 terms, let's look at the numbers. We have a negative 3, we have that's a 1 right there, we have a negative 12, and we have a positive 1. And it turns out that actually none of those numbers have a common factor. The only common factor they have is 1. Okay, that's the guarantee that if numbers have nothing else in common, they at least have a 1 in common, because 1 goes into every single number. In terms of the variables, they also don't have any variables in common. Y cubed over here, there's a y here, but not in the last 2 terms, and there's no x's and z's in most of them except for this term right here. So actually the greatest common factor there is 1, and we can't factor this at all. It's already there's no common factor that we can pull out, so we just stop right there. So what I circled, the original problem, that actually is the answer. All right, this next one is a little bit trickier because there's obviously 4 variables here, but we can still use our same kind of procedure that we used before. So the greatest common factor, let's start with the numbers 16, 96, 56, and 8. And I would be tempted to use this smallest number 8 as the greatest common factor. So 8 goes into itself, that's true. It goes into 56, it goes into 96, and it goes into 16. So that definitely works. It could not be bigger than 8, because the biggest number that goes into 8 would be 8 itself. So at least you know that you're not going to have to check any number larger than 8. So 8 is the number part. What's the variable part? Well, I'm looking at the q's. This last term doesn't have any r's at all in it, so r cannot be part of the greatest common factor. Neither can p, because even though this one has a p, the others don't. So the greatest common factor in terms of the variable will be something with q. This has 2 q's, that has 2 q's, that has 3, and that has 3. So it looks like they have a q squared in common, because that's the smallest power of q. So let's divide each of these by 8q squared, and we will put that in front of the parentheses like we did before and see what's left behind. So the first term, 16 divided by 8 is 2. Q to the third divided by q squared, if we subtract 3 minus 2, we get q to the first. And then we still have that r squared. The r squared doesn't have anything to divide it, so we'll leave it as is. Okay, this one right here, negative 96 divided by 8 is negative 12. Q cubed divided by q squared, 3 minus 2 again with those exponents would be 1. And then this p right here has nothing to divide it, so we'll leave it as is. Okay, right here, 56 divided by 8 is 7. Q squared divided by itself cancels, and this r stays where it is. And then finally, we have 8 divided by 8 is just 1. Q squared divided by q squared is also 1. So that last term is 1. That's our factored answer right there. So that's a pretty important skill. There's a lot of factoring problems where you'll have to pull out the greatest common factor as a first step. So I recommend definitely watching out for that in future problems that you may have to solve.